So now we find a solution of a question problem. So here, find the linear fractional transformation, that is Mobius transformation, that maps minus I 0 I in the z plane onto the points minus 1 I 1. Okay, and the second part is that into what curve is the imaginary axis s equal to 0 transformed under the mapping. Okay, so here in the question you see that I have written here, find the linear transformation. That means there exists a unique linear transformation that transforms minus I 0 I onto three distinct points minus 1 I 1. Okay, so here in the next video I will show you that there exists a unique linear fractional transformation or unique Mobius transformation from any three distinct points in the z plane to three distinct points in the w plane. Okay, that we will do, but just using the properties of Mobius transformation this problem can be solved. So let us consider that w equal to az plus b over cz plus d, where AD minus BC is not equal to 0, be the Mobius transformation. So we want to find the Mobius transformation that transforms minus I to minus 1, 0 to I, and I to 1. Okay, so we have that, which is the simplest one we can consider. The simplest one is this, 0 transforms to I. So therefore we have that in the Mobius transformation A z equal to 0 plus b c z equal to 0 plus d, and that should be equal to what? This is transformed to I, so therefore it is I. So from here you see that b equal to id, and because ad minus bc is not 0, this condition should be there, so I must have that these two are not 0 here. In this case these two are not 0. Alright, so w equal to az plus b, instead of b I have what? id and cz plus d. So we want to find what is a, b, c, d. So we have already related d and b. Okay, so now the second point is what? The third point, I transforms to 1. So I transforms to 1, this becomes your w equal to 1. Now I equal to what? Z equal to I. So ai plus id and ci plus d, and from here you see that it is ci plus d equal to ai plus id, and this implies if I multiply both sides by minus I, then it will be c. So I multiplied it by minus I, this by minus I, so it is a, and this is d. So let this equation be 1. Right, then what is the other point? Third point was what? This one, minus I goes to minus 1. Right, so minus I goes to minus 1. So minus 1, this is your w now. So your z equal to minus I, z equal to minus I, id and id. So from here, if I transfer this to side, then I will see that this is ci minus d, and this is minus ai plus id. And if I multiply by minus I, then you will see that this is minus c minus id, and this is because it is multiplied by I multiplied by I, so it is a, and this is minus d. So let this be 2. And what is equation 1? So equation 1 was this. Equation 1 is this. So this is 1. So from here, if I add, then I will see that this implies if I add, then twice I equal to, this is cancelled out, so it is what? Minus twice I d. Okay, so that implies your a equal to minus id. Okay, so a equal to minus id, and from here what is your c? I can say you just subtract, and if I subtract this, so I will get that twice c equal to twice d. Okay, twice d, and that implies that c equal to d. So all a, b, c are connected to d, so thus your w equal to az we got id z plus b was id, c is d, and d is d, and because d is not 0, so iz plus I and z plus 1. So this is the Mobius transformation that transforms the 3 points, these 3 points, minus I2 minus 1, 0 to I2 1. And once you find this, you can verify, because when z equal to 0, you see that W is I. Similarly, if z equal to I, so if z equal to I, so you see that this is I plus 1, and z equal to I, it is I plus 1, so it is 1. So okay, similarly you can verify for z equal to minus 1. Alright, so it is, this is the, which is the required Mobius transformation. Okay, so now the second part is that your, to what curve the imaginary axis x equal to 0 is transformed. X equal to 0 is what? Okay, so x equal to 0 means this is the imaginary axis, x equal to 0. So in the z plane, so what will be the curve in the corresponding W plane? Okay, so we need to find. So how will you find it? Okay, so we need to find what curve x equal to 0, this one is transformed to here. Alright, so in the next video I will show that.